Dear students, welcome to the session. Today we are going to discuss encoders. Encoder is a combinational circuit which encodes the data, which encodes decimal or alphabetical data into coded form, which is nothing but encodes. Means if you are having a decimal value, that will be converted into a binary code. Similarly, if you have a decimal octal value, that will be converted into a coded form, like that. So encoder is a combinational circuit which encodes decimal or alphabetical data into a corresponding coded form. There are different types of encoders. That first one is octal to binary encoder and hexadecimal to binary encoder decimal to BCD encoder, and fourth one is priority encoder. Okay. Now we'll design this octal to binary encoders and hexadecimal, decimal and priority encoders. In this, we have octal numbers. That octal numbers we need to code it into a binary values, right? That we need to design. To design this encoder, basically we require truth table, right? So I am considering truth table here. Truth table is what? It will always give the relation between input and corresponding output values, right? So here the inputs are what? Octal numbers, which are octal numbers are always 0, 1, 2, 3, 4, 5, 6, 7. So I am considering it is data of 0, D1, D2, D3, D4, D5, D6, D7, which are the inputs. To represent this octal number, at least we require 3 digits, right? So I am taking it as A0, A1 and A2. So 0 corresponding binary is what? 0, 0, 0. 1 corresponding binary number 0, 0, 1. For 2 it is 0, 1, 0. 3, 0, 1, 1. 4, 1, 0, 0. 5 is nothing but 1, 0, 1. 6 corresponding binary number is 1, 1, 0. 7 corresponding binary number is 1, 1, 1. Right? Now, we need to find logic expression for each outputs, right? Here the outputs are 3. So we need to find the logic expression for each outputs. For A2, right, the logic expression is what? We need to consider only when the output values are high. For A2, output is high only for D4, D5 or D6 or D7 values. So A2 I can write as D4 or D5 or D6 or D7. For all this value A2 is high. Similarly, to get the expression for A1, consider only output high cases. So A1 is high for D2, D3, D6 and D7. And third one is A0, and A0 is high for D1, D3, D5 and D7. Right? Now we know the logic expression for each output. So I can develop logic diagram. To draw the logic diagram, consider all possible inputs here. Here inputs are what? D0 to D7. So consider all the inputs D0, D1, D2, D3, D4, D5, D6, D7. Right? So first A2 is what? Which is D4 or D5 or D6 or D7. All are OR together. So give it to one OR gate. Right? A1 is high for this expression, which is D2, D3, D6 and D7. Give it to OR gate. So you get A1. A0 means D1, D3, D5, D7. Give it to OR so that we will get A0. So in this way, we can design octal to binary encoders. Next one is decimal to BCD encoder. In this, decimal numbers are coded in terms of BCD values. So decimal means inputs will have 10 inputs. D0, D1, D2, D3, D4, D5, D6, D7, D8, D9. 0 to 9 means 10 inputs. These decimal numbers we need to encode in BCD form. For the BCD, we will have only a 4 bits enough to represent the BCD numbers. So I will consider that A0, A1, A2, A3 are the BCD output. So this is decimal input and these are BCD outputs. Now the thing is, we need to find the logic diagram which exists in this decoder, right? So for this, first we need to develop the truth table. Truth table is always gives the relation between inputs and outputs, right? Here the inputs are decimal numbers. So decimal numbers are always from 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? 10 decimal numbers. I will consider it as D0, D1, D2, D3, D4, D5, D6, D7, D8, D9. 10 inputs. We need to find outputs, BCD outputs, which are A0, A1, A2 and A3. Right? 0 decimal value we can represent in BCD, it is 0, 0, 0, 0. 1 means in a binary numbers 0, 0, 0, 1. 2 means 0, 0, 1, 0. 3 is 0, 0, 1, 1. 4 means 0, 1, 0, 0. 5 in binary is 0, 1, 0, 1. 6 in binary is 0, 1, 1, 0. 7 in binary is 0, 1, 1, 1. 8 is 1, 0, 0, 0. 9 in binary BCD number is 1, 0, 0, 1. Right? Now we know the output values. So from this we can find the logic expression for each output. Right? As we are having 4 outputs here, which are A3, A2, A1 and A0, we need to find the logic expression for each output. I will consider only the values when A3 is high. Right? So for A3, these values are high only for when D8 or D9 is high, then A3 is high. Right? Similarly, for A2, just consider only these cases, because during these cases only your A2 value is high. So which are D4, D5, D6 or D7. For A1, output high for these cases, which are D2 or D3, D6 or D7. For A0, output high for these cases, which are D1 plus D3 plus D5 plus D7 plus D9. Right? So from these logic expressions, we can develop the logic diagram. As we are having 10 inputs, I am considering the inputs D0, D1, D2, D3, D4, D5, D6, D7, D8, D9. These are the 10 input lines and 4 outputs, right? So for A3 means D8 or D9, give it to one OR gate so that you will get A3 value. A2 means D4, D5, D6, D7, which are OR together to get A2. A1 is D2, D3, D6, D7 all together to get A1, and A0 is D1, right? D3, D5, D7, D9, give it to one OR gate to get A0. Right? In this way, we can design decimal to BCD encoder. Next we'll see hexadecimal to binary encoder. Hexadecimal to BCD means in the case of inputs we are having 16 hexadecimal numbers. So this is binary. The third one is hexadecimal to binary encoder. Means here we are having 16 hexadecimal input numbers which are coded into binary numbers. Right? So I am considering one decoder. Which is having hexadecimal inputs which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 9, A, B, C, D, E, F. 16 inputs and which are represented in binary. So to represent 16 values in a binary number system, we require 4 bits. So I am taking output values are A3, A2, A1, A0. Right? So now the thing is we need to find the logic diagram for this decoder. So to get the logic diagram, first we need to develop the truth table. Right? So here the truth table is always gives the relation between inputs and corresponding outputs. Here outputs are what? A3, A2, A1 and A0. Right? And inputs are hexadecimal numbers which are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, A, B, C, D, E, F. These numbers I can consider as, let's take D0, D1, D2, D3, D4, D5, D6, D7, D8, D9 and considering A like 10 for the better understanding, D11, D12, D13, D14, F means 15, so D15. Right? So here we are having 16 inputs, 0 to 15, so 16 inputs. So we need to find first corresponding binary code. Right? So 0 we can represent in binary as 0, 0, 0, 0. 1 means 0, 0, 0, 1. Right? 2 means 0, 0, 1, 0. 3 is 0, 0, 1, 1. 4 is 0, 1, 0, 0. 5 is 0, 1, 0, 1. 6 means 0, 1, 1, 0. 7 is 0, 1, 1, 1. 8, 1, 0, 0, 0. 9 is 1, 0, 0, 1. A is 1, 0, 1, 0. B is 1, 0, 1, 1. And C is 1, 1, 0, 0. D is 1, 1, 0, 1. E is 1, 1, 1, 0. F is 1, 1, 1, 1. Right? Now we know the truth table, means we know the output values for each A3, A2, A1 and A0. With that, we can find the logic expression for outputs. As we are having 4 outputs which are A3, A2, A1 and A0. Just consider this output values when that value is high. Right? So A3 is high for D8 to D15. So consider all possible D8, D9, D10, D11, D12, D13, D14 plus D15. Right? And A2 is high for these cases, right? Which are D4 to D7. D4 plus D5 plus D6 plus D7 and D12 plus D13 plus D14 plus D15. So A1 is high for only this period. So only consider the corresponding inputs, which are D2 plus D3, D6 plus D7 plus D9 plus 10 plus 11 plus 14 plus D15. And A0 is high for D1, see, A0 is high for D1, D3 in all these cases. So I can write D1, D3 plus D5 plus D7 plus D9 plus D11, D13, D15. So as we know the logic expression, we can develop the logic diagram. To draw the logic diagram, consider all possible inputs here. Here the inputs are D0 to D15. So take all the input lines D0, D1, D2, D3, D4, D5, D6, D7, D8, D9, D10, D11, D12, D13, D14, D15. Right? Total 16 lines from 0 to 15. Now, A3 is high for D8 or D9 or D10 or D11 or D12 or D13 or D14 or D15. So give it to one or to get A3. Okay. So A2 is D4, D5, D6, D7 and D12, D13, D14, D15. Give it to one or to get A2. Right? A1 is D2, D3, D6, D7, D10, D11 and D14, D15. So give it to one or to get A3. A0 is D1, every alternate. So I can consider D1, D3, D5, D7, D9, D11, D13, D15, give it to one or so to get A4, right? So this is the logic diagram for hexadecimal to binary encoder. Okay, thank you.